Hello, my name is Matt, and on behalf of my collaborators and co-authors at UCL, I'd like to welcome you to this overview of our tutorial called the Basic Augmented Reality Demo. So, if you're new to this, what is augmented reality? Well, augmented simply means we're adding something, and the reality is, in medical terms at least, what the surgeon or clinician is currently looking at. So in slightly more detail, here we're showing a picture from laparoscopic liver surgery. We've taken a CT scan and produced this 3D graphical model here. That's these vessels that you can see. And we overlay that or add that to the reality that's represented by the video feed from the laparoscope, normally displayed on the video monitor. So how do you get started in this? Well, if you've been around a while, you'll notice most systems have some form of video camera calibration. Then you've got to do some alignment of your preoperative data to the intraoperative video. So one way of doing that is point-based registration. So we first make and calibrate a pointer. We then teach about point-based registration, and then we put it all together to give this augmented reality overlay. So this BARD provides tutorials that you can do at home. We developed them during the pandemic, so they had to be simple and doable at home with homemade stuff. We did this by breaking it down into each component part. So we have a separate tutorial on video camera calibration, where we're using our mobile phone to calibrate the laptop webcam. Similarly, we take a mobile phone and we make a pointer out of it, and then we demonstrate how you track that and calibrate that to make a calibrated pointer. And then we show how these pieces can be put together into an augmented reality display. Here we see how we're tracking a phone, and then to the right you can actually see an additional image, kind of mimicking what you might have with a picture-in-picture type ultrasound display. Where we're actually just feeding the video back in on itself. And in addition, we've provided a game so you can play around and you can learn and understand what the effects of the number of fiducials or points and their distribution around a target of interest and how that affects the registration accuracy. So in short summary, it's all in Python. We've provided software and Jupyter notebooks that you can run. The most fiddly bit is probably the AR overlay, but we've provided a widget for you, again in Python and using VTK. And it just remains for me to say that this is part of a much bigger course that we've developed at UCL called Computer Assisted Surgery and Therapy. Here's the URL, computerassistedsurgerycourse.net. All of this is open source and provided for the community, so feel free to take a look, provide bug fixes and suggestions, and even contribute sections to this course so it can be an online resource for years to come. Thank you very much.